Hello everyone. Today I'll be taking you through the step-by-step process of creating this robot. I will cover its modeling, coloring, rigging, and finally animating its walk. And this will be part of a video series. The animation playing in the background? I'm going to break down the process of making it in the upcoming videos. So stay tuned. If you haven't subscribed to the channel yet, subscribe now and hit the like button if you enjoy my content. Also, if you encounter any issues or have any questions, feel free to drop a comment below. I'm here to answer and assist you. Let's begin by removing the default camera and light. Switch to the X-ray view and adjust the lower half of the cube on the X-axis to create the main head of the robot. Apply the scale and bevel the backside using Ctrl+B with a segment value of 7 and reduce the shape value. Now add a cylinder into the created cutout space from the bevel. Rotate the cylinder in the Y-axis and delete half of it. Insert the side face of the cylinder, then extrude it outward. Use the spin tool to extrude and rotate the face. Spin tool always uses the cursor to rotate around, so we need to place the cursor carefully. Also, I reduced the number of steps to minimize the vertex count. Insert the face once more, extrude it towards the main head, and add the mirror modifier to create a mirrored version on the other side. Add some random details by inserting faces. I did it randomly because it will be in the back and won't be in the main focus. Now apply smooth to the object and add a bevel modifier. Extrude the lower two faces of the head object and rotate them slightly to align with the rotation of the back object. Add a bevel modifier to the head, set the segment value to 2. After that, apply Shade Auto Smooth and enable the Harden Normals option in the bevel modifier. Add another cylinder. This will serve as our screen. Rotate the cylinder to the X-axis and scale it down. Select the cylinder first, followed by the cube, and press Ctrl+/ to cut the cube into the shape of the cylinder. Ensure that your Bool tool add-in is activated to execute this operation. Additionally, ensure that the Boolean modifier is positioned before the bevel modifier in the modifier stack. Now add a cube, scale it down, and extrude faces randomly. Once more, use this modified shape to cut into the main head object. This will add more details to the model. Create another cube and use the bool tool to perform a similar cut as before. These cuts will enhance the detail of the model. I've already implemented 2 more cuts, but feel free to add more if desired. Just remember not to overdo it, as each cut increases the vertex count. Add another cube, scale it down, and align the rotation of both side faces with the head object. Go to the front view, select the outer face, and slightly rotate it using the shear tool. The shear tool allows adjusting the edges of the object without altering its overall shape. Next, insert the face and use extrude along normal to extrude the face inward. Add a bevel modifier to the object and switch the miter outer option from sharp to arc. This adjustment will change the outer sharp edges into rounded ones. Resize the object, then bevel the corner edges. Select the top face, insert it, and then delete the face. Now, select the outer edge, press Ctrl+F, and use grid fill. Set the span to 3 and then separate it by pressing P. Insert additional loop cuts to the separated object and add a wireframe modifier to it. Add a cylinder and use it to cut the head object with bool tool. Also, shift the object slightly upward to prevent it from looking entirely flat. Add another cylinder beneath the head. This will serve as the connector to the main body. Apply loop cuts to the object and bevel them. Next, extrude them inwards. Then add subdivision to the object using Ctrl+2. Also insert the lower face to smooth out the object. Snap the cursor to the selected area and then add a rounded cube. Change the operator preset to quad sphere and lower the arc value to 7. Select the top faces of the quad sphere and delete them. Then choose the top edges and scale them on the Z-axis. Select the shapes that were used to cut the head object and move them outwards. This is just to add some variation to the cuts, but it's not necessary to change their appearance. Fill the quad sphere with F. After that, insert it and extrude it outward. Then add a bevel modifier with harden normals checked. Select the corner triangles on all 4 sides of the quad sphere, then insert them and extrude inward. This will form our leg section. Add some more details by inserting faces on the top. Now, select the quad sphere and rotate it in the Z-axis at a 45-degree angle. Snap the cursor to the leg section and add a cylinder, then shape it into a somewhat pipe-like form. Then, once more, snap the cursor to the cylinder and add another cylinder. This will serve as a connector between the 2 segments. Select both sides of the cylinder, insert them, and then extrude them inward. Insert the selected faces again and delete them. After that, choose the deleted outer edges and press Ctrl+F to perform a grid fill. Now, select the cross faces and insert them, then extrude the inserted faces. Create an edge in the middle of the object and delete the other half that hasn't been edited yet. Add a mirror modifier and mirror the object in the Y-axis. Now, apply the modifier, bevel the middle edge, and extrude it outward. Then, add a bevel modifier to smooth out the object. Duplicate the first part and make slight changes to the shape to avoid an identical appearance. Once again, snap the cursor to the end of the joint and add another cylinder. This will serve as the second joint. Add a cube and shape it like a claw, since this will be the object that makes contact with the ground. Feel free to shape the last part as you wish. Here I opted for a somewhat claw-like appearance. Here, I kept the joints design similar to the other one, but feel free to add more details according to your preferences. I also reduced the size of the leg part to match the main body, but larger legs would work just as well. Enhance the details of the leg segments by inserting additional faces. Additionally, ensure that the origin of the objects is consistently set at the starting point of each object. For the final segment of the leg, I kept the design straightforward by inserting some faces for added detail. Feel free to enhance the leg's appearance further by incorporating wires or other elements as you see fit. In the bigger joint, I used the same cross pattern but pushed it inward to make it look different. I also adjusted the scale of some parts as they seemed a bit large. Now, snap the cursor to the first part of the leg and add an armature. Rotate it in the x-axis by 90 degrees. Go to the Object tab and in the Visibility section, check the In Front box. This will ensure the armature is always displayed in front of all objects. Here, I extruded the armature to connect with the joints and extended it to the last part of the leg that will make contact with the ground. Afterward, switch to Pose mode and press Shift+I, then select to New Empty Object. This will add inverse kinematics to a new empty object. Now select the first two parts of the leg, then Shift-select the armature, and enter Pose mode. Press Ctrl+P to parent the objects to the bone. Perform a similar process for the remaining leg parts. With this, the IK leg will be ready to be moved. Now enter Pose mode, select the last two bones, and in the Bone tab, lock the X and Y for both bones in the Inverse Kinematics section. Next, select the middle bone and give it a rotation with a Z value of 0.430. Select all the lower parts of the body and rotate them by 45 degrees in the Z-axis. Select the empty at the bottom and snap the cursor to it. Add a circle curve and edit it to resemble half of a circle. Now select the empty and add a constraint of Follow Path. Set the target to the curve. With that setup, you can move the leg by changing the offset value. Set the first keyframe at 0, and after 20 frames, change the offset to 100 and keyframe it. Now, select all the leg parts, duplicate them, and rotate by 90 degrees in the Z-axis. Press Shift+R to duplicate the objects with the same rotation value. If your objects look messy, start by rotating the curves that are not already rotated at the front by 90 degrees. Afterwards, apply the location of all the empty objects. This will fix any issues. Now, select the empties and give them linear extrapolation by pressing Shift plus E. This will make the offset change depending on the current frames without adding any new frames. Give the front right and back left legs a difference in keyframes of 10. You can introduce a slight variation in keyframes for each leg to ensure they don't all move in the same manner. Here, I cleared the rotation of the empty objects to improve their look, but it's optional. Now, select all 4 armatures and parent them to the body. After that, create a separate collection for all the objects related to the head. Then, snap the cursor to the middle of the head and make an instance of the head collection. This will allow the head to move quickly and enable the ability to change head shapes anytime. Now parent the instance to the body. For the body, add a keyframe at rotation, and then add a noise modifier to get continuous movement to the object. Add an empty cube. Then, select all leg curves and the body, and parent them to the new empty cube. Using the empty as the controller, you can move the entire model without any issues. We can add more detail to the legs without repeating the same changes to every leg. Here, I extruded some faces of a leg segment and the joints. To implement this, select all the legs and then choose the leg with more details. Press Ctrl+L to link the objects by object data. Add a loop cut to the top face of the body object. Duplicate it and separate it by pressing P. Choose some random edges from it and separate the selected edges again by pressing P. Now, convert both objects to curves and give them depth from the Curve Data tab. Give one of them a slightly smaller amount of depth to introduce some variance, then add subdivision to it. Duplicate both objects and reverse the depth size. Finally, convert them to meshes. Add more loop cuts to the middle of the object. Select some faces from both sides and extrude them inward. Also, make another loop cut around the whole quad sphere, bevel it, and then extrude them inward. Now hide all the collections and then enable the main head collection. Duplicate the base head cube and remove all modifiers except for the bevel modifiers. Then, delete all the faces other than the front two faces, and scale both corners towards the middle. Now, add edge loops and scale them on the z-axis. Then, separate them from the object. Delete the previous object and subdivide the newly separated object's faces 2 times. After that, select the middle faces and subdivide them again. Here, select 4 faces from each corner and use the loop tool to make them circular. Then, delete those faces. Add a solidify modifier to give it some thickness and ensure that the even thickness option is turned on. Afterward, duplicate this a few times around the head with some slight variation. Now, apply the Boolean modifier to the screen object, then delete the front face of it. Afterwards, select the outer edges and extrude them inward. Once again, extrude and merge the vertices at the center. With the remaining edge in the middle, scale it towards the center and bevel it to add more edges. Now, select the middle vertices and use proportional editing to make it a bit rounded. Afterward, disable the main head collection and turn on the invisible collections. Currently, the leg animations are continuous. To create a resting position for the leg, keyframe the offset in the timeline where you want it to stop without giving a new offset value. Then, press Shift+E in the timeline and give the newly created keyframe a constant extrapolation. Repeat this process with the other legs to achieve a stop motion effect. You can set the stop motion at any keyframe you desire, since the offset value linearly increases over time. Also, provide each leg with a different stopping time to enhance the overall appearance. In the graph editor, we can observe that the curves are smoothing out even before reaching the keyframe. With this curve value, the animation will start slowly, continue linearly, and then slow down before coming to a complete stop. In our case, we want the leg to stop rather suddenly. Additionally, if you select the keyframe in the timeline and hover the mouse in the graph editor, then press the dot on your numpad, your graph will zoom to focus, eliminating the need for scrolling. Now, to make the body stop moving, go to the Modifier tab in Graph Editor, then turn on Restrict Frame Range. Give it an end value where your legs are stopping. In my case, my leg animation stops around 160 keyframes. Since the movement is stopping suddenly, you can give it some blend out value. Add a plane. This will be our ground. Ensure that the plane is touching the robot's legs, or the robot will appear to be floating. Now, make the floor larger and shape it like a room. Here, I added a camera and aligned it to the view without moving it manually. You can align the camera by view by pressing Ctrl, plus Alt, plus 0. This will align the camera to the view you are in your viewport. Then, for the lighting, I opted for a simple 3-area light setup. Switch the render from EV to cycles. This will provide us with better-looking lighting. For the color management, keep it as Ajax and change the look to medium-high contrast. There isn't much to say about lighting, because it can be adjusted based on personal preference. If you don't want to use a manual light setup, you can always try using HDRI images to achieve the desired lighting. For the ground, I opted for a simple cross-pattern image. I didn't fix the stretching of the texture here because it won't be visible from the camera. The color palettes I used will be included with the main blend files on Gumroad. Right now, there's a major issue with the head. Whenever you try to color it, all the cut object's colors and the base color will be the same. This happens because we haven't applied the Boolean modifiers. Select the head instance and place it inside a new collection named head. Choose the instance, then press Ctrl+A and select Make Instances Real. Now, select all the objects, with the empty head object being the last one. Press Ctrl+P to parent them as objects. Select the screen and scale it up before applying all the modifiers. Now, select all the objects that have Boolean modifiers and mirrors on them, and apply them. Applying bevel isn't required, but it's okay to apply them, as we won't be making any new changes to the objects. Here, I will be coloring the object with the custom palette I have created before. You can give it the same color from the palette, or use your own color if you prefer. Now, select the screen cover object, duplicate the face on the front, separate it, and place it inside the cover, as this will be our new screen. Then give the screen a dark green color. Now, duplicate the screen again, make it smaller, and edit it to look like an eye. You can give the eye any type of expression you want. Also, make sure that the eye object is in front of the screen, or the eye won't be visible. Create another duplicate in front of the eye and add an effect by applying a brick texture and scaling it. With this, the coloring ends. To enhance the emission effect in cycles, add a glare node in the Composite tab before the Composite node. The emission is looking a bit too intense, so increase the threshold value to 2.3. Now, your model is ready to be rendered. Thank you for watching. Don't forget to like and subscribe, and stay tuned for the upcoming video in this series.